Okay, test, test, test. Welcome, welcome. A lot of people who have been here in Second Life for ever, and perhaps some newcomers. We usually do this, if you haven't been to to the Science Circle recently, we usually do this for about an hour presentation. Please look at the schedule coming up. There's some really fine presentations in August and September from people I really want to hear from. Today, what I'm doing is a little different format. I'll be in voice and chat, and I do not want to be the only one talking. Please chat. Please say anything, anytime, questions. I'll answer them as we go along. That's why I'm here. Okay, what I'd like to do today is I'd like to present about 12, quick view of about 12 different scientific, exciting discoveries. Some of them are brand new discoveries. Some of them are follow-ups on old theories. And so let's begin. Just for, if you haven't met me yet, I am in Texas. I am the department head for computer information systems and cybersecurity systems in San Antonio. And I am proud to have been with Science Circle for about 8 years now. Okay, so let's start off. Let's say, what is science? I start asking my students the same thing. I have a Bachelor of Science. I teach a Bachelor of Science degree, a couple of them, and I ask my students, what is science? Why are you here? What is science? Anyone? Keywords, chat. What is science? What do we mean by science? Okay, a system for organizing thought. That's a good. But what kind of thought? What do we talk about in science? What do we do in science that we don't do in some other fields of organizing thought? Methodology for studying and understanding. Okay, and that's a good definition because what part of our world? Is it the world inside our head or is it the world outside of us? And testing ideas. All of those are important because, and it can be both, absolutely. In other words, the only way for us to observe the world is from our heads, from our experiences, our senses, and then our perceptions, and that's how we view the world, and then we look and see if there are things that are new. Basically, science differs from other means of organized thought that it deals with the things that we can see and measure or see evidence of and stuff. It's not about the philosophy of love, or it's not about supernatural beings' effects on the world. It's about the seeing. But science isn't science with other people. So part of what we're doing here is science. It's sharing what we've learned and know, and seeing how other people, seeing if they experience the same thing, and sharing things we've discovered. And that's how science evolves. Science is not a doctrine. I had a person in the audience last time that talked about science being somewhat of a doctrine. If science is being taught like a doctrine, it's not science. Science is constantly changing. The whole idea of science is to question and to observe, and if things that we observe don't fit into a neat box, then we change and modify and grow in science. That's what's so exciting about it. A century ago, we didn't have a lot of science. It was a burgeoning field. In about a century before, or even less, it had become a branch of itself from natural philosophy. We didn't have a lot of way to measure things. We didn't know a lot. There were people about 100 years ago, like Lord Kelvin, that said that we knew everything and that we only needed to measure more, a little bit more precisely. But around the same time, we discovered radioactivity, relativity, and quantum theory, and expanding universe, and all of that. We found out in the last century that we really know so little. So what have we discovered, do you think, in the last 20 years that's really, really exciting and breathtaking, really new? Anyone? What have we discovered in the last 20 years? Yeah. Now, Higgs boson is kind of the last little part of the puzzle on the standard model that we started messing around with in the 50s, particularly 60s. And it's nice that it's there, that we've discovered it. We're trying to find out more about it, but it is the nice little piece in the puzzle. Nanotechnology. We're definitely going to learn more about quantum computer engineering. Absolutely. Quantum computers and DNA computers. If you're not familiar with those, you're going to be seeing them in the future. Quantum computers are actually starting to come out. Gravitational waves, they were thought of, or at least they were part of theory nearly 100 years ago, and now we've actually found them. Exoplanets. To me, that's one of the more exciting things because it basically says, I mean, anyone who knows about astronomy knows that the Earth and the solar system is a tiny little dot among hundreds of billions and billions of other things. And it's kind of amazing that there's so much space out there and we're just one dot. And to think that there's no other planets, no other people, or living things would be somewhat depressing. So actually knowing about exoplanets and some that are Earth-like is one of the more amazing things. Let me go on to a couple that I think are amazing as well. Anyone know what we're looking at here? Yeah, as a matter of fact, one of the other people in the last session said the brain, and in a way it's like that. This galaxy filaments, that's exactly correct. What you're looking at is a small part of the universe. Every one of those dots is a galactic cluster, really. And what you're looking at is filaments that are evidence of dark matter, because they're the structure. Dark matter, we don't know much about it, but we do know that there's enough of it, about a quarter of the universe, that helps to structure matter. It helps to structure galaxies and all of that. So what you're looking at is the universe. You are there. You're like an infinitesimally small little dot on there. Well, everything's part of the universe except for your thoughts. I guess they're part of the universe also, or things you can conjecture. Another thing I think that's fascinating in the last 20 years is what's this? In other words, the first one about dark matter is that we don't know much of what's out there. Only 5% of the universe is matter like we know, which includes the Higgs boson, etc. There's about a quarter that's dark matter and a couple, 2/3 that is dark energy, and there's only about 5% that we really know much about. That's exciting. That means there's more science to come. So what are we looking at here, do you think? This has got lots of symbolism in it, but it's another one of, it represents another really, really important thing we've discovered in the last 20 years. Heme, okay, in other words, a heme molecule like you'd find in um, red blood cells. Yin yang, now that's important here. Photosynthesis, all this sort of thing. What we're looking at, the reason why the yin yang is this is a very, very abstract concept of the idea of the microbiome and photosynthesis and the whole bit. The idea is in the microbiome, we have discovered that we are not we. In other words, we're a collection of about 1 trillion cells all working together that make us human, but then there's 10 times as many cells which are not human. In other words, they're bacteria and other things all over our skin, inside of us. So we're really, as you walk around, there's a huge cloud of these bacteria everywhere. Every time you touch something, every time you're exchanging bacteria, every time yeah, I get the bleach. Well, the interesting thing that we've discovered is that you don't want to get the bleach. In other words, you are part of this and it's part of you. So the yin yang means, in this case, the good and the bad. In other words, what you really want to do is you want to foster the good in you. You want to keep your gut microbiome and whatever on your skin and stuff. And so they've actually found that kids who have dogs and play in the yard and stuff are healthier as adults than people who are sterile and live in a sterile environment, which is pretty cool because I like to go play in the garden and stuff like that. And I'm not a neat freak, so that's an interesting discovery in the last 20 years. Okay, what's this guy? Yeah, exactly. Absolutely. I get along pretty well in my biome, I hope. Okay, what's this guy here? Anybody know? As I mentioned, Jess knows what this is. Anyone else? I mean, it's a bird. It's a chicken. Okay. Yeah, it's a cute little finch. I think it's cute. It's called a zebra finch, and it's native to Australia, and it lives kind of in the outback where it gets hot. And the hot can vary from like hot to like really, really hot. And so what they found was a postdoc at Deakin University. Now, Deakin University I've heard of because one of my students is doing a study abroad at Deakin University this semester. And one of the ladies there is doing postdoctoral work, and she was listening to the various sounds that the male and female on the left insert were talking back and forth about, is it really my turn to sit on the nest? Do I have to, or whatever? And so they're conversing about this, and they found that the things they say to each other, basically the chattering they say to each other is very different than if they're alone on the nest. All of a sudden, if they're alone on the nest, they have another little song, and they were wondering what this was, and they found that they may be singing to the eggs. And they did an experiment and found, yes, indeed, what they basically did, and I like this as science, is they took about 175 of the little eggs. They raised them in a constant temperature environment. Some of them they kind of played back this little song to. Others they didn't. Then they put all the eggs back in the nests and saw what happens. And what they found was, human mothers have known for some time that yes, babies can hear. And so you talk to them, you basically you imprint your voice, and like my wife was saying, if the husband isn't around, doesn't talk or argues or whatever, it can impact the kid too. And the siblings and the whole bit of the family. But what they found was that when the little baby finches were raised in warm temperatures, they were actually only the ones that were sung to were smaller, and the other ones were the same size as the other finches. Now, why do you think that in a hot environment you'd want to be smaller? Anybody guess that? Why would you want to be smaller in a hot environment? Yeah. Okay. Absolutely, that's exactly correct. In other words, thermoregulation, food, all the types of things that you would expect, maybe less. And so if you were smaller, you would have more of a chance of survival. Now, this is very fascinating because it's not just embryos listening to their parents, but the parents actually able to control something about the development of the child. Absolutely. Day and CB and everyone. But in other words, the parents can actually control the embryo's development and the development of the child by saying things to them outside. Now, this is something startling and unexpected, and they're wondering whether it happens in other parts of the bird or animal world. So stay tuned. This is a new discovery, and we'll learn more about it. Okay, what have we got here? Somebody said it looks like Yellowstone, or it could be. I thought it looked like maybe Grand Tetons nearby, but this is what you may have seen if you were one of the first people to populate the North America during the last glacial period. Absolutely, to me it does. Looks like Alaska, or not. Basically, what is the theory? Does anyone know how people got to the Americas? And yes, that's correct, is that the predominant theory, although there are a lot of other possible theories, but the predominant one that they have some evidence about is that there was a land bridge called Beringia. Basically, you can see what it looked like up in the upper right. You can see 20,000 years ago where there was a bridge and then ice blocking the way. Um, yeah, from the Revenant. By 10,000 years ago, when agriculture was beginning to um, become an invention or something that we did in the Mideast, the land bridge had disappeared, and then you can see what it looks like today. Now, one of the things about years and years ago, during before around 10,000 BC, is that the uh, ocean level was lower. In the Ice Age area, it was by 400 feet or 100 and whatever it is meters, maybe 130 meters, which is quite a bit, which exposed a lot of land, including the land bridge. Well, it exposed more than that, is that if you look at the yellow arrow, that's the way they think that the very earliest people may have come. In other words, there was, if you go to Western Canada today, what do you see? Anybody been to Western Canada? Well, if you go to Western Canada today, you're going to, and or the Alaskan Panhandle, you're going to see, yeah, not a lot of people. If you're in Vancouver, yes, but basically it's flooded valleys. There's what looks like islands were basically part of mountaintops, and so there was really quite a coastline back in the Ice Age areas, and they think that people walked more or less onto the coast, or they could have gone by boat. Especially now, one of the things about going by boat is that if you look at the genes of the earliest people, like in the area of the Haida, if you've been up to Vancouver, that's one of the people up there. And if you look at some of their genetics versus people that are in the middle of North America, they're a little different. So what they found is that some of the genetics of people that were early in the Americas um, are similar to the people that are native to northern Japan, particularly the Ainu or the ancestors of the Ainu, and other people who are indigenous to Japan before people came over from China. Um, so it's very interesting. There's a lot of speculation about boat trips through the Kuril Islands and Kamchatka, and then down through Alaska and into the Americas, because that area may have been ice-free. So this is an old theory. Now, one of the things about one of the new discoveries was people were doing DNA testing of the lake beds up and down the area that they thought, the inland route. And what they found was until around 12,000 BC, which is too late for some of the peoples that they know in North America, is that there was no vegetation or not enough vegetation or animals to support migration through an inland route. It would have had to have been after about 12,000 years ago. And so, because this is like 1,500 miles walking, and it's not something you can carry that much food in your backpack or something. Okay, anybody, what does this look like to anyone? This is kind of in my field. Ah, okay, that's very close, as a matter of fact. Have you worked with punch cards? That's how I first started programming back in the 60s. Yeah, it could be the suburb of someplace like Arizona. Yeah. But what this actually is you're very close with the punch cards because each of those dots is a 1 or a 0. And this is actually part of a speech by Richard Feynman back in the 60s. And let me show you a little bit more about what I mean. Is when we say ones and zeros, that's how computers store stuff. If you were storing what I'm saying right now, or storing each of the objects that we're in, or each of the colors, or the letters in the word hard drive, you'd be storing them as patterns of ones and zeros. Something simple like a capital H is 8 ones or zeros. We store them different ways. One is by, like Mike Shaw's talking about changing the magnetic polarization of parts of the hard drive. If you have a DVD or Blu-ray or CD, you actually create these little pits by a laser beam. But in any case, they're all ways of saying 1 or 0. Presence of something, absence of something. Two different states of something. Now, to give you an idea of how small we're talking about with those dots, here are some very small objects. Up in the upper left is a red blood cell. Relatively speaking, this is like a cruise liner that's going up into the Alaska Panhandle. It's huge. It's 10,000 billionths of a meter in size. A smaller object, like an E. coli bacteria, you see is smaller, but it's like a big house compared to some of the other things. You might notice that to the left and bottom, there's a tiny little thing. That's the polio virus, and it's only 30 nanometers, or 30 billionths of a meter in size. So how big are these little dots we're talking about? Well, the purple is the size of that polio virus. In other words, each of the dots you see are actually chlorine atoms. And so we are at a technology right now where we can store or arrange in array individual chlorine atoms. So like the very bottom left, absolutely, end polio now. I remember in my day where people actually had polio, and Jonas Salk and his vaccine. We'll talk about vaccines actually in a minute, and that was a big deal back then. Sabine, absolutely. Okay, so down at the very bottom, if you look at that, there's like 2 dots, and then there's 1 below it, and then there's another 5 dots. That's 8 total. And the way you read that is actually 001 00000, and it stands for a Y. Okay, so these are individual chlorine atoms. Can you see on the person's finger that there's a tiny, tiny little cube? I actually circled it. Anybody see that? Well, that cube is 1 millimeter in size. Well, with these chlorine atoms, this is a new way of coding that they've found out. With these chlorine atoms, you can create a cube that is 1,000th the size of that little cube, and it can store every book ever written, every video, every image, everything you can think of would go into that one little cube. So in the future here, yeah, it really is wow. And so in the future, can you imagine a computer you could carry around on your finger, or at least taped to something that can basically store everything there ever was or is? Yeah, exactly. Space travel archives. Or some of you guys may cringe about this, but a chip under your skin that basically gives you all knowledge there ever was, sort of thing, so you don't have to remember it. Okay, so as this res is in, what are we looking at here? What does this look like in, or to you? Yeah, vaccination. Okay, absolutely. This is actually a flu shot. The graph to the bottom left shows how many people yearly die of flu because they didn't get the shots. Um, well, that's you're right. There are people who believe that vaccinations are give you stuff for a lot of reasons, like other myths or other things about science. But the idea is that there are hundreds of thousands. In the case of the upper left there, you'll see 500,000 or so people who die of flu without, let's see, can the cubes? Ha ha ha. Well, the interesting thing, see, is that let me digress for about 1 minute on what you just said, Dave, because what did MIT do? What did MIT do back in the early 2000s that educators were aghast about? What did MIT do? Yeah, if you select the wrong spot, you're going to get a hematoma. They put their courses online. Oh my goodness. Oh my goodness. They gave away the farm. Everybody's going to learn openly for free. Um, but as we know, learning is what we're doing now. Learning isn't content. In other words, you could have all of this content so you don't have to memorize it. Learning is social. Learning is learning from other people. Learning is thinking, putting things together, synthesis. So you can put all of the contents online. In fact, actually in 2009, MIT also did something more alarming, and they basically said, okay, here's the content, but also here is how you can present it in classes. Knowing very well that education is not something that you do, and it's not just simply content. Problem solving, critical thinking, all of those. You're not going to learn that just from reading. Okay, so what is it about these vaccines? When should you take a vaccine? Anybody know? When is it the most effective? Okay, yeah, that's actually interesting. It's early, I would say, like early in life, but also early in the morning. From 9 to 11, the study basically shows that it's 4 times as effective as at, say, 4 or 5 p.m. Absolutely. Now, interestingly enough, if you're going to get infected, it's also going to be in the morning. In other words, you're 4 or 5 times as likely to get affected in the morning as it would be in the afternoon. Now, this makes sense with vaccines because essentially some vaccines are dead viruses. And so what happens is your body senses these dead viruses, which cannot make you sick. But what happens is, what do? Anybody know how a vaccine works? Why do they put dead viruses in you? Or in the case of the very earliest vaccines back in the early 1800s, cowpox, which instead of smallpox. Absolutely. In other words, your body sees these foreign objects inside, and they race to the rescue, and they look at them, and they measure them, and they see how what can we do? And they create antibodies and other things, and so the next time they see that, they go, invader, invader, and they now have lots of these little antibodies to run over and take them out before they infect your body. So that's essentially what happens. And yes, as your body, you may feel mildly different as your body races toward these benign invaders that are in the vaccine, but it doesn't contain live stuff that it can kill you, or it contains extremely small amounts of stuff. In other words, this is to help you be healthy, not to hurt you. Why do we need this? Well, what is this? Anybody know what this is? What's this? What could this be? This graph here of the world, or part of the world. This is the Zika virus. This is how far it's spread. Absolutely, that's it. You're right. This is the place where the Zika virus has spread recently. Is there a cure for Zika? Janine, yes, I'm not playing down that. I'm not playing down that for some people that they get effects. I and in some cases serious effects. By and large, in the population, I'm not a medical doctor. I'm a computer person, but by and large, if you're talking 500,000 people who die yearly of the flu, is that vaccinations have been proven to help save hundreds of thousands of lives. Yes, and I would be too. But the idea of the Zika is there, for example, in the Zika virus, there is no cure for Zika. And there may be in the future as we have changing climates and people traveling places and such, something that spreads much more quickly and is more lethal than things like the Zika virus. So one of the things that you can do is what? The microbiome and such. If you keep your microbiome healthy and you help develop your immune system by eating and sleeping and all the things they tell you to do, is that you may be more likely to be able to fight off things which are nasty for you. Speaking of circadian rhythms, what do we see here? Yeah, probably my students too. Tired students. Okay, this is not the recommended way to do things. Um, okay. But it's not the recommended way to do things. It's essentially people that stay up all night mess up their circadian rhythms. They're more likely to get a cold or something. They also have found that, of course, sleep deprivation can reduce your ability to be able to think critically, problem solve, that sort of thing. And the longer that you go sleep deprived, the more likely that you can actually affect yourself physically. So it's a part of our circadian rhythms, and we can't shake it. Speaking of needs, what do we see here? Yeah, wasting water? Well, actually, taking water from a clean source is what yeah, maybe he's not very careful, but the idea is he's putting water into a jug, which may very well, yeah, hopefully, although there's far worse as far as things can be in water. But yeah, that too. In other words, the whole idea is that clean water may be something that a lot of people don't even think about. But for a majority of people on Earth, clean water is a precious luxury. Some people have to hike for miles and miles even to get dirty water or semi-contaminated water. So it has become more scarce. So where would you get clean water from? What are some ways to do that? Rain, if you collect it, and the rain is a spring, absolutely, if you happen to be near one. Fancy straws. Now, what do have the fancy straws in them? Deep wells, the fancy, as long as it doesn't become drought, an aquifer if you're lucky and it doesn't run out, like in the United States we're talking about. Ocean, okay, CB. Squeeze sands, that's interesting. The fancy straws have filters in them. Now, one of the largest, you can remove it from the ocean, and that's kind of where I'm getting at, is desalination. One of the largest sources of water, of course, is the ocean. And right now, the filters that they use are, yes, it's expensive because the filters that they use are not easy to create. They're very sensitive to certain chemicals and such. You have to replace them often. They're not reverse osmosis is the process to do that. So what they found, though, is that they have discovered much less expensive films, and also they're looking at carbon nanotubes and other devices to keep the salt on one side and the water on the other. And this well, so they've made some discoveries in this area, and they're thinking that what they may be able to do for some areas is to make floating desalination plants that can not only get fresh water, but possibly hydroponics and other things. This is a fairly recent discovery. It's much like a more efficient solar panels thing. Okay, what are we talking about here? When we're talking about the human mind and needs, okay. Anybody happen to be on Oculus? Is Oculus still compatible with Second Life? And Stefano, you must have read about what I'm going to discuss because that's kind of what I'm looking at. Yeah, and it can be. But what they found is that for paralyzed people, or people that are paralyzed, say from the neck down, um, as I mentioned in the last time, you did? Okay. Um, there are places in Second Life. There's one in particular that's called Virtual. Let's see. It's I'm trying to remember what it's the name of it, but basically the owner avatar is named Gentle Hera, and she runs some spaces where there are people who are mobility impaired, as she is. And they find it very psychologically comfortable to be able to have an avatar where they're able to walk and jump and dance and interact in ways that they would like to. And so what they found for paralyzed people is that if they are in a virtual world, they not only get the satisfaction of being able to interact in ways that they would like to, but they made a startling discovery. And so they'll put them in a virtual world to begin with, to kind of get their minds trained, and then they try something else. And one of them is this. Anyone know what this is? A lot of the pioneering work here was in Japan, and then also I think in the United States. Yeah, Virtual Ability is the island I was thinking about. I was trying to remember what it is. If you haven't been over there or some of the islands, it's a fantastic place. Been around a long time in its Second Life, and it's yeah, virtualability.org. Okay, so what is this? This is an exosuit. What is an exosuit? Anyone know? Yeah, there you go. Basically, that's what it is. Essentially, you can, well, except they exist today. Essentially, they can be used for, they're working on them right now to be able to um, help people's backs when they're lifting things all day long. So basically, you can come up and easily lift 250, 300 pounds using the English measurement system and not hurt your back. Same thing with other types of duties where you have to lift or move heavy objects, that sort of thing. But yeah, there you go. Okay, the idea is that, and Stefano has mentioned a couple of things. They actually found the most fascinating thing is that they found that not only could people use their brainwaves to move these, but that when they move these, it actually helped retrain some of the nerves that had been, if they were not totally disconnected, it actually helped retrain some of the pathways so that they could actually find that they were moving. In other words, they had more mobility simply by the physical therapy and being in virtual worlds and being moving around, and so their brain was able to help reconnect nerves. It's a most amazing discovery they found. Okay, we actually have a couple visitors today, and one of them is to the right of the slides, and I've asked, or at least, let's see, was it Jess or Chantal brought her in here to watch because we knew that there was going to be one. And what is this? What type of animal is this? Not the ship. Yeah, you guys. It seems like everybody's read that, or a lot of people have read it. This is what's called a Greenland shark. A Greenland shark is one of the largest predators on Earth. But the reason we haven't heard much about it is it lives up north. It's big enough to eat polar bears and seals and possibly the diver up there if he gets too close. Somebody said it looked cute, as long as you're swimming alongside it, I suppose. Um, but what they found was that if you were to try to age us, what would you do? In other words, if you had a human and you wanted to find out what age they were, what would you do? Yeah, as a matter of fact, uh, the University of Iceland was doing this presentation, and I was actually I didn't meet the people doing it, but I happened to visit the University of Iceland about a year ago. Okay, telomeres is an interesting idea. In other words, the little frayed end, so to speak, on DNA. That would be one way to do it. Count birthday cake. I like that. Radiocarbon dating. Okay, so let me talk about the radiocarbon dating. Is now in living things, we refresh our cells. So if you were to say, for example, find out the date of a blood cell, you would find that all of our blood cells in our body are pretty much refreshed every 20 days because they're important. And so it's difficult to find a cell in your body which is as old as you are. So for the Greenland shark, what they found was there's proteins in its eye that they dated by radiocarbon dating and found out, oh my goodness, this shark is 400 years old, give or take about 120 years, but that's still amazing because the longest living thing that we knew before was about 211 years old. So a 400-year-old shark. I don't know whether it's the cold water or, the diet or or they sleep well or something, but any case, that was a new discovery. We know very little about some animals like this. We're still learning about them. Oh, you mean like contact lenses? Or are you talking about lens on their eye? Yeah, I imagine they have a lens on their eyes because they're able to see well, just like and focus. Particularly predators. Predators have really good and stereoscopic vision, that sort of. We actually have had eye experts in science circle. Okay, this is kind of an interesting view. Now, you're talking about Greenland being cold or Greenland sharks in cold water. This is much, much colder. This is in the close to minus 300 degrees centigrade. And what they're trying to do here is they're trying to create metallic hydrogen. Why would you want to create metallic hydrogen? How does electricity work? Anybody? Yeah, there you go. You guys have been reading about that too. Is essentially a superconductor. Now, what happens if you put a lot of electricity through a copper wire? Actually, Patio, I'm going to get to that one next. Although, actually, it'll be Saturn and not Jupiter. It can melt if you put too much, or at the very least, it gets really hot. I mean, that's how a toaster and a light bulb works, the old style ones. So what actually happens is that, okay, yep, a lot of energy going into heat rather than into transmission. So what actually happens is electricity works when, what is a metal? Okay, let's ask that. In other words, when I say metallic hydrogen, what is a metal? Okay, what the word metal means is, yeah, there you go. What the word metal means is that basically the electrons on the outside of the atom are very loose, and it's really easy for them to say jump over to the next, yeah, there you go, share electrons. It's really, really easy for them to jump over to the next atom. So essentially it jumps over to the next atom, knocks off that one, and keeps going. We call it flowing, but they really don't flow. They just kind of go from atom to the next atom, and then it goes to the next atom. It's more like pushing each other. But essentially, that's what we call electricity when it happens. And so a metallic object is one that electricity flows through easily. Now, a superconductor is one in which there's no resistance. So in other words, it doesn't heat up. It's totally efficient. And call it the holy grail or the quest for this type of materials is to find a superconductor at room temperature. Most superconductors, you have to have very special cold conditions, but they're thinking that metallic hydrogen may be a superconductor at room temperature. So they're trying to create metallic hydrogen. What this would do would be to save an enormous amount of money and wasted energy. Yeah, keeping it might be a challenge, but hey, you know, we've risen to those challenges. That's right. Pressure, temperature, all that good stuff. But under special circumstances, it may be very useful in, like, say, in areas where we can do that. Now, the arrangement of the hydrogen, you can see what's called the phase 2, 3, and 4 over there from the top and bottom on the right. And what they're thinking phase 4 may look like is on the bottom right. And then solid metal hydrogen. Where do we find solid metal hydrogen, metallic hydrogen, right now naturally? Not on Earth. And someone said, yeah, absolutely. In other words, where there is a lot, it's very cold in the interior. They think that anyway, that in the middle of Jupiter and Saturn, there's metallic hydrogen. One of the things that, much like, in fact, how come we have a magnetic field on Earth? Yeah, you jump to that's right. In other words, a liquid iron core or a solid iron core in the very center. And the idea is that, and then it rotates. That's right. And so just like electricity is created for us, in order to be able to have computers, where you've got basically magnetic rotating and then creating electricity through wire, and that it's being transmitted through wires. Essentially, the core of these planets and our own planet rotate and create a field, magnetic field. And Jupiter has a very, very strong magnetic field, so that's what they think is happening. And so one of the things that happened recently, which is rather amazing, is this is one of the moons around Saturn. Has anyone been following the Cassini-Huygens type of project? It's been around for a while. Oh, yeah. Yeah, absolutely. Yeah, I know Patio will be. And the idea is that back in December, the Cassini, which you can see up in or at least a depiction of it in the upper right, decided to get down really, really close to a moon called Enceladus. Now, that's how I pronounce it. If maybe you can tell me what the real pronunciation is. But basically, it's one of these ones that spew material out of the core, and they think it's from oceans underneath. And so it went down close enough to be able to measure these spewing geysers or geysers. And what they found was not just water. That's what they were looking for. Is that what would have to be there in order to have life? What would you have to have? What would the ocean have to have, much like our ocean has? Carbon, absolutely. In other words, when you talk anything that's called organic, the reason my first degree was in organic chemistry. Okay, so anything organic means carbon. But not just, and you're right, not just methane or ammonia, which are very, very simple carbon compounds, but what they found was complex. If you zoom in on the slide there, you'll see that the fifth column, 1, 2, 3, 4, 5, or the sixth over on the right, basically says complex organics. So they didn't just find real simple ones. They found things like amino acids and sugars and lots of complex types of things. And that sounds like soup for bacteria. So it's much like the people who did not find the ones that were looking for people populating the Americas. They didn't find DNA of plants and flowers and stuff that indicated that humans could not have lived off the land. If they had not found some of these things inside the ocean of this moon, it would be unlikely that there would be anything down there living. But now that they found this, they go, whoa, here's basically a soup. It's a broth. And so the next thing, of course, they want to do is go out and see if there really is anything living in the oceans. Yeah, when you're talking about Stanley Miller or Harold Urey, cosmic soup experiments in the early 50s, the reason I know about that is somebody asked me what I did for a little bit of research I did at NASA. I worked with a scientist called Dr. Cyril Paruma, and he actually worked with Stanley Miller and Harold Urey. And he kind of took over after them in the late 60s, and I did some experimentation on what's called pre-biological formation of primitives, which was essentially looking at building blocks of DNA and whether you could replicate them in the same types of cosmic soup experiments that you did back in electric arcs and stuff. In other words, can you, with something simple like ammonia, methane and stuff, can you create more complex organic molecules? Absolutely, the primordial soup. Okay, so what I've done today is I've kind of given you an overview of very exciting new discoveries. Some of them brand new, like the zebrafishes and the thing they found with the virtual reality and exoskeleton. And others are more elaborating on old theories. And for most of the people here, and I noticed some people that are maybe new. In fact, the person in front of me, High Flyer from IEEE, I don't know if it's your first time for Science Circle, but for anyone that's new, welcome. But if not, this is what we discuss here. And so what I'd like to do now, we've got about 10 minutes, and so do you have any questions? Are there anything that you have been looking at that you find particularly interesting? Science in the news. Sure, go for it. Yes, please. That may be easier.
Good. This is Dave Miami. Can you guys hear me? Hello? Yes, we're good. Okay. Earlier this week, I was invited to attend a session here in Southwest Virginia, run by Senator Mark Warner, and those of you in the U.S. may be familiar with him. He was our governor for I think 4 years, and he was talking about the future. He was a businessman, a capitalist, as you self-proclaimed capitalist, and now a politician. But Vic, my question to you and other people in the audience was a comment that Senator Warner made, which is that he feels the future of careers that people should be getting into is coding. He said, if I was governor again, I'd make every student, you're going to love this, Vic, every student in Virginia take some kind of computer programming coding class, certainly a lot more math. And I was dying to ask a question, and he left. And I guess my question to you, Vic, is what kind of coding should students be getting into, in terms of computer science, technology? I'm thinking something like cybersecurity is red hot these days. Things like app development are sort of, in my mind, are on the back burner. What's your feeling about that, Vic?
Well, okay, the first thing I think everybody should do, and I think a lot of people have, is go to a website called Hour of Code. I don't know if you're familiar with that, but coding is simply talking to the computer, as you know, and but you have to learn how computers think, so to speak. Hour of Code is a site where I have actually personally introduced people from 4th grade up through as old as you can get, and it talks about the different ways in which you can talk about computers with branching and loops and such like that. Obviously, we're speaking English, but we could just as well be speaking another language. So the language to me is not so important as the understanding about how to talk to the computers. Now, in our field, we talk. I mean, we teach C++, not Objective C, but we do stuff with, of course, SQL and JavaScript and PHP and Python and Java and all the ones which you'd think about. I don't think there's a particular language which I would recommend so much as the idea of how do I create this, the thought process, the logical algorithms, the step by step. That's what I would really try to get people into. I mean, if they can get that far, then we can talk. Does that make any sense?
Sure. I guess what I'm thinking of is, you're pointing out about how there's going to be mass storage of information. And that graphic of, that millimeter square, and think of 1,000th of that storing all this kinds of information on there is awesome. I guess we're at the point of, well, then there's access. If I'm sitting here, how do you access that information? But eventually, I presume that's going to overcome. So education is not going to be so much about teaching rote knowledge, but it's going to be, what do you do with it? How do you interpret? How do you analyze it?
That's actually very astute. And what they found is that even in the early 2000s, they were talking about the semantic, let's see, I'm trying to remember what the term was then. The idea is we're overwhelmed by information. So it's not a matter of being able to access it. Anyone can Google and find millions. It's being able to do something with that and to discern what's real information, what's pseudoscience, all of that. And where I think we're going is to AI systems. In other words, letting the computer find stuff for you, but being able to talk to the computer so it can understand. We have a device by my wife has a device by a bedside. It's called Alexa. I don't know if you've ever worked with that, but essentially you can ask Alexa anything or a lot of things, and it's an AI system that helps you discern. So I think in the future we're simply going to have something that is with us, that looks like maybe a hearing aid or glasses or that's on our collar, and that will help us to filter and discern and sort information. It just has to get to know us better. So the more we talk to it, the more we look, the sites have targeted ads right now. The not pop-ups, but if you go to Facebook or anything, it has ads that are targeted to you. I think that's where we're going. If you have enough money, of course, you can get a supercomputer like Watson to help out. So the doctors are using that for making medical decisions. In other words, you don't have to remember all of the counterindications of medicine and the patient's charts and all that. All that can be in the computer, and the computer can look at that, and then you can make intelligent decisions based on real knowledge. Does that make sense? Yeah, in other words, knowledge is just stuff. Like I try to tell my students that there's kind of 4 different levels. There's data. In other words, if I say 42, what could that be? That could be the answer to, the meaning of the universe, or it could be a waist size or an age or who knows what. Information is where you're able to pair data together, 42 kilometers. Knowledge is where you're able to take that information and now apply it to a real situation. And then wisdom, I think, this is kind of my own definition, is being able to apply it to a real situation only in a way that benefits people and that is so you know about people as well. Singularity, yes. Actually, I have that exact book on my shelf near my desk. The idea that we will, I mean, we're doing it now. Look at how many people here do not, and you don't have to say it, but how many people don't have a digital device on them or right next to them? We're starting to become just like that. In other words, just because we're not loading our minds into a hard drive yet or have a chip like I was mentioning doesn't mean that we're not going that direction. In other words, I think that we can use artificial devices and hard drives and stuff to benefit us without losing our humanity. So yeah, I think we're definitely going towards singularity. With somebody mentioned quantum computers earlier, is that with the capability of quantum computers, we will soon be at a stage where computers can outthink us and have more storage and think faster and stuff. So we can use that capability to be more human and to be able better to engage with the world because we don't have to have faux pas of cultures and stuff because we will be warned about them and we will know other people's languages and all of that. Our interactions and our knowledge of other people will increase. So singularity is not I'm not a conspiracy theorist. I don't think that some of these things are bad. I think if we're human and smart, we can use. Okay, and so it is now, what, 11 o'clock in Second Life time? Well, yeah. Okay, thank you. Yes, and so I will wrap it up. If people like this format where we talk about science in the news, please, feel free to come forward yourself and let's get some stuff together. If you're not comfortable with speaking, I'll be glad to be your voice. If not, there's a lot of people in the audience here who have presented before. If you haven't been to Second Life or Second Science Circle, even if you can, look at some of the exciting new presentations we have coming up in August and September. And I heartily invite you to do that. Also, science is all about socializing and sharing what you know. So make friends and talk about stuff after this hour. We have definitely not known everything, and more science is ahead, and it's very exciting time that we live in. So thank you for the opportunity of sharing some of this with you, and thank you for being here and sharing things with me. That's why I'm here.